Alright, good day guys, how are you all doing? So I'll be talking about row echelon form and reduced row echelon form. And actually these two niggas here, they actually focus on just two certain things. REF, it is the ref for Gaussian elimination. RREF is the ref for what? For Gauss-Jordan elimination method. So how does this actually move, or how does it operate? You know, I've actually introduced you guys to elementary row operation. So you see the process at which we stop in that point where we actually use what we call back substitution. That's by bringing out the remaining values and sub them normally. That point at which we stop, whereby you are going to be having a leading one at the first point, the second point, the third point. Then you have zeros as a normal. Then just for us to get, you know, 1 1 1, I guess you guys should know what I'm talking about if you are the person that what you've actually revised or you've go through my previous video on elementary row operation step by step. So what does row echelon form place matrix to be? It says that a matrix that is in row echelon form will have all these certain properties. The first property is that any row that has entirely zero, that means that if you see a particular row 1 consists both in an augmented matrix form. If everything is zero, that means that what? That certain matrix is actually possessing the properties of what? Of row echelon form. And also you see that no matter any zero matrix you can see, that's any row you can see that is entirely zero, it can never be placed up. It will all be placed at the bottom of the matrix. So the second thing tells us that for each row that does not consist of zero, the first non-zero entry is always 1. And if you guys could remember when I was telling you guys, I will bring a practical or a normal aspect to explain all this with the matrix. So what they mean by is that, let's assume we have a certain particular matrix like this now. It says for each row that does not consist of zero, that means if all the rows is not entirely zero, like I'm just trying to use this as an example, is always at the bottom. So if this row does not consist entirely of zero, that means the number that we need here in order to what? To work out with respect to row echelon form, it must have a leading one. That is, you can have what? A leading one at this particular point here. How you get what I'm saying? So let's say 4. So this is what I'm talking about, that what? If it does not consist entirely of zero, you can have what we call what? A leading one. That's a 1 at this point here. Now the second thing tells us that if for two successive non-zero rows, that means if you have more than just a single row that we have just explained here, are you get what I'm saying? The leading one in the higher row is farther to the left than the leading one in the what? In the lower row. We call it forming step. I will show you practically. So the third thing tells us that a matrix in row echelon form is in reduced row echelon form. Are you get what I'm saying? Now, how can the matrix has to be processed to what we call row echelon form first before you can now break it down to reduced row echelon form. That means that for a reduced row echelon form, any matrix that is in reduced row echelon form must pass through row echelon form first before it moves into reduced row echelon form. So it says a matrix in row echelon form is in reduced row echelon form when every column that has a leading one has 0 in every position and below what? It's leading. Don't worry, I'll use matrix to explain and visualize that. Then the last thing I want you to know is that, like I told you, that a matrix in reduced row echelon form is of necessity to be in what? Row echelon form, but not conversely. That means that a matrix in row echelon form cannot be in reduced row echelon form. How you get what I'm saying? Only if the solvings actually move it through that particular aspect. Your own focus is how can I break it into row echelon form. But if the solvings of your matrix actually move it to a reduced row echelon form, it still counts as a row echelon form because that is the process you take. Now look at what I'm trying to explain with this theoretical thing I just said. Now if you look at these certain 3 categories now, these 4 categories. The first category tells us that any row that is consisted entirely of 0. Now if you look at the whole 0, in this point now, this is a reduced what? This is a row echelon form because it's the properties of what? Of row echelon form. The second tells us that for each row that does not consist of 0, like I told you, the first non-zero entry will be 1. The first non-zero entry has to be 1. They call it leading one. So this is also the properties of what? Row echelon form. The third thing tells us that for 2 successive non-zero rows, that's if you have a certain 0 that they are totally not entirely, you don't have 0 entirely there. It says the leading one in the higher row, this is the first higher row, this is the lower second row, this is the lowest. So it says that the leading one in the higher row is going to be farther to the left As you can see now, look at the leading one in this point here, the left. Look at this one again. So you can see that this one is going to be far away to the left from the other ones. So they form what we call step, like I told you. So look at now, just like a step, as you can see. So the leading one is going to be far to the left than the leading one in the what? In the lower row. As you can see, this is far to the right. The leading one in the higher row is far to the what? To the left. This is also a property of what? Row echelon form. So the next thing is that it says that a matrix in row echelon form is going to be in reduced row echelon form when every column that has a leading one, every column, this is, I guess I've told you guys what they call column. This is column, this is row. So this is column, this is row. Vertical aspect column, horizontal aspect row. So it tells us that if every column that has a leading one has 0 in every position. Now look here, now look at the first column. It has a leading one, the rest is 0. Look at the second column. It has a leading one, the rest is 0. Look at the third column. It has a leading one, the rest is what? Is 0. In this kind of position, this is what we call a positioned a positioned row. This is a row, a reduced what? Row echelon form. So hope you understand what row echelon form and reduced row echelon form is trying to talk about now. So this is an example of a reduced row echelon form. A process whereby you are only having leading one, and in that vertical first component the rest is 0. Leading the second leading one, in that vertical component the rest is 0. The third leading one, in that vertical component the rest is what? Is 0. So let's look at an example and let's look if you could actually clear your doubts and answer it correctly. Okay, this is a reduced row echelon form, this is a row echelon form. Let's see that. Alright, so now if you look at this now, we want to check out, you can pause the video and check this out, try it out and see if you can actually get it, that which one of these are in row echelon form and which one is not in row echelon form. That's what we want to check out for this. So, and we have to use the properties that we have actually laid down for it to understand and to get the certain ones that are in row echelon form. Now, even without stress, I could easily say that this is actually in row echelon form. Why? Based on the third properties. The third property tells us that what? For every leading one, if there is leading one in all vertical position, if there is a leading one in the first vertical point, are you get what I'm saying? The whole particular matrix, the whole particular values in that vertical point will become 0. Now if you look at now, it does not follow this particular step, obviously, right? But the second thing now tells us that, look at it, the third law tells us that whenever there is a leading one in the first row, the other one, the highest leading one, will be further to the left. And as you can see, look at the highest leading one, look at the lowest leading one. You can see that it is further to the left. So therefore, it will form a step. And for it to form a step, that means that what? This is a what? This is a row echelon form. Are you get what I'm saying? So the second thing now, when you look at this, literally when we take a look at this, this is 1. Okay, we know it has a leading one, but listening to what is being said, the question tells you that if it has a certain particular leading one, that does not really make it entirely a what do they call it? A what do they call it? Row echelon form. You have to look at every properties of it. Now, if you look at this now, look at the 0. I would actually agree with you if you tell me this is a row echelon form, but that is wrong. Because I instructed you that the zeros, whenever you have a full 0, it has to be at the base. That's the lowest bottom before you can call it a row echelon form. So therefore, this is not a row echelon form. Even though the first property is actually what? This first property is actually what is there, but this has spoiled it for it not to become a row echelon form. So the third one of this now, automatically, when I take a look at this very, very well, we have what? We have to think extensively. And what is the extensive part that we need to think extensively? That we look at the first point. The first point tells us that what the leading one, the leading first row, the value has to be 1. This has actually attained that, right? And also again, as you can see, the law tells us that it usually forms steps. But even as to ignore that step aspect, automatically since the leading value is already 1, automatically this is a reduced, this is a row echelon form, because there is no other particular things that intercept, or let me just say that intercept the law at this particular point. Are you getting what I'm saying? So who can tell me something? I want to ask something. Is this particular matrix, is this a consistent matrix or an inconsistent matrix? And What kind of solution does this particular matrix contain? Try to think that out also. Does it contain a single solution? Does it contain no solution? And does it contain many solutions? I want you to think of that and drop the answer in our comment section. So this is a Rref echelon form. Tricky, right? Thank you.